Okay, guys, in this video, we're going to talk about simplifying fractions. We are going to talk about simplifying fractions. So when we say simplifying fraction, and this is what we are going to talk about today. And even before we start simplifying fractions, we need to talk about two concepts, okay, to simplify fraction. The first one is prime factorization. And the first one is prime. I am going to write it here, prime factorization. And as I'm telling you this, if you're thinking about simplifying a fraction, it has to be through one of these two concepts or methods I'm going to give you right now. The first one is prime factorization. And what is it? What is a factorization? Factorization, this term in itself, factorization, is when you are writing a number or an expression using different factors. Okay, to write an expression or a number as a product of two or more numbers. So factorization in itself is the writing of a number or an expression as a product of one as a product of two or more numbers or expressions, as a product of two or more numbers or expressions. And prime number, because the word prime you see here, the word prime has something to do when you factor a number. So when I say prime, a prime number is a whole number greater than 1, which has only itself and 1 as a factor. Okay, a prime number is a number that is greater than 1 and has only 1 and itself as a factor. Prime number, okay, is a number that is greater than 1, okay, and has only one or itself. One and itself has only one and itself as a factor. So let me give you the prime numbers. Some of them I'm going to give you. And 1 is not a prime number. I want you to know that 1 is not a prime number, because according to the definition of a prime number, it has two factors, 1 and itself. 1 and itself. So if it has only, because 1 in this case has only itself as a factor, so 1 is not a prime number. The first prime number is 2, and because 2 has 1 and itself as a factor. The next prime number is 3. It has 1 and itself as a factor. The next prime number is 5. All right, we see I skipped 4. 4 is not a prime number. 4 is a composite number or compound number because it has more than two factors. We'll see that as we move along. The next prime number is going to be 7. And 8 is not. 9 is not, because 8, 9 have more than 2 factors. 10 is not, but 11 is another one. 13 is a prime number. 14 is not. 15 is not. 16 is not. 17 is a prime number. 18 is not a prime number. 19 is a prime number. 20, 21, 22, not prime numbers. 23 is a prime number. I'm going to stop here, guys. I'm going to stop here because the prime numbers have only 1 and itself as a factor. This is a prime number. And if we talk about prime number, we can tell you a composite number. A composite number is a whole number greater than 1, is a whole number greater than, is a whole number greater than 1, and as, because trying to delineate prime numbers and composite numbers, is a whole number greater than 1. Okay, we know that it has to be more than 1. That is not a prime number. And it's a greater number. It's a number greater than 1 that is not a prime number. So 2 is not a composite number, but 4 is, for example, of composite numbers. Get 4, 6, 8, 9, because all these numbers and so on, all these numbers are composite numbers. So we get prime number here. I want you guys to make a note of these because we're going to use them later on to simplify fractions. Okay, and this is prime. This is prime numbers, guys. This is what we're going to hold on and make sure that you pay attention to this, and you, if possible, you understand this or write this down, because let's go and find the prime, because we're going to use that. We're going to find the prime factorization of some numbers. We're going to do that right now. Prime factorization. So you know that what we're going to do, to factor whatever number I'm going to give you, we need to decompose that number into its prime factors, because prime numbers, and then after that write this as a multiplication or a product of 2 prime numbers, a product of 2 prime numbers. So this is, let's go and do some prime factorization now. Let's say that we get this number. This number is 50. Okay, we get 50 here. Let's go and find find the prime factorization of 50, and I'm going to write this here: prime factorization. Okay, let's go and find the prime factorization of 50. So whenever we're doing this, we take that number and we make 2 branches. Okay, 2 branches, because what we're going to say, we're going to divide this number, because 50 is even. 50 is even, and is even. When I say 50 is even, let me give you some rules for even numbers. The number is even if that number ends with 0, 2, 4, 6, 8, and so on. It's like you counting by 2s. Okay, so this is, all these numbers are going to be even. That's why I say 50 ends with a 0. That's why it's even. And numbers, I'm going to put this one here as well. a number that is odd, numbers that ends with 1, 3, 5, 7, 9, and so on. Because these numbers, if the number ends with a 0, 2, 4, 6, 8, and so on, that number is even. If the number start with 1, 3, ends with 1, 3, 5, 7, and 9, that number is odd. So in other words, what I'm saying here, I put those dots, usually 3 dots. I put those dots, so I start counting the first the numbers that end with those digits. Okay, so now let's go over here. We take 50, we divide 50 by 2, because whenever the number is even, okay, you can divide it by 2. So what you put the 2 here is 50 divided by 2. If you take your calculator, guys, take your calculator, divide 50 by 2, you get 25 here. Okay, and remember, according to the definition of prime number, so 2 is a prime number. Every time you find a prime number, you take it and you circle it, because you will use it. Well, this is 2, and we're going to work with the 25. 25 is not a prime number. 25 is a composite number, and we're going to keep working with the 25 until we hit prime numbers. So 25 is 5 and 5. Okay, and so we have 5 here and 5 there. So do you think 5 is a prime number? Yes, according to that definition, 5 is a prime number. So we stop here. We stop at the prime numbers. So what you have done here, you take that 50, you write 50 here, okay, and you are using, and you're finding the prime factorization of 50, and what you do, you take all the one you've circled. You take these 2 here. That's 1. It's all multiplication, guys, because it's a factor. And you take this 5 over here, and you take this 5 over here. So in other words, 50 is equal to 2 times 5 times 5. So the 2 times 5 times 5, we call this prime factorization. Prime factorization. Why prime factorization? Because they are all prime numbers. 2, 5 are prime numbers, but at the same time you factor those terms, because by definition of factorization, it's an expression. It's a way to write an expression or a number as a product of 2 or more numbers. The product, this is the multiplication here, of 2 or more numbers. So basically we get 2 prime numbers here. So this is called prime factorization. And since you get the 2, 5 here, you might want to, if you want to be a little fancier than that, you can write 50 is equal to 2. And since I haven't spoken about exponents yet, but let me assume that some of you who are watching this video understand exponents. So we get 5 taken 2 times as factor. So we might write a 5 here and we square that. So we say 2 times 5 squared. So these two prime factors are the same thing. So 50 is equal to 2 times 5 times 5, and 50 is equal to 2 times 5 squared. So we have found the prime factorization of 50. Let's go and try to find the prime factorization of another number. And 189, for example. 189. And we get that 189 here, guys. So when you take a look at this one, this is not, take a look at what we have here. 189. And we said that if a number ends with a 0, 2, 4, 6, 8, and okay, that number is even. But if a number ends with 1, 3, 5, 7, 9, that number is odd. So in this case, the number ends with the 9. It's odd. We're not going to divide this by 2 because odd numbers are not divisible by 2. So it has to be a 3. So how do I know I need to put a 3? Because the number is odd and 3 is my first odd prime number. So I divide this by the first odd prime number. I take my calculator and I say 189 divided by 3. Whatever I have here, guys. Whatever I have here. So if I get 189 by 3, that's one way to split this. Okay? That's one, because if I take 63 by 3, so 3 times 3 is 9, and 3 times 6 is 18. So this is 189, so I can put 63 here. See? 3 times 63 is 189. And this, and since 3 is a prime number, you go back to your prime numbers, you know that 3 is a prime number, you just circle that, because we will need that. We will need that prime number. All right? And once we finish with this, let's take care of 63, because 63 is not a prime number. We need to keep milking it until we get to a point where it's all prime numbers. Okay? And let's go and decompose 63, because 63 is a composite number. So 63, once again, this number is odd. We divide by 3. So 63 divided by 3, it's 3 and 21. Because 3 times 21 is 63. 3 times 1 is 3. 3 times 2 is 6. And once again, you go, and this is another prime number. You keep it here. And let's go another one. We get 21. 21 is a composite number. We can still decompose that to 3 and 7. Yes, 3 times 7 is 21. We stop here now. You know why we stop here? Because we get all our prime numbers. We cannot go any further. We cannot go any further. So what we do, we just circle those. And these are the prime factors of 189. And the last thing we do, okay, the last thing we have to do is to rewrite 189 into its prime factors. So I'm going to take 189. This is equal to 3 times 3 times 3, right? So it's all multiplication. 3 times 3 times 3. 1, 2, 3 threes times 7. Okay? Times 7. But you know what? I can write this. How many times have we taken 3 as factors? 3 times. So I can write it 3 cubed times 7. Guys, this is the answer. This is prime factorization. Prime factorization. This is, we will need the prime factorization to simplify fractions. And let's go and simplify this fraction using prime factorization. Okay? We're going to go and simplify this fraction I'm going to give you right now by using prime factorization to separate this fraction here. So the fraction is 30 over 36. That's the fraction. And we're going to use prime factorization to factor, or to simplify this fraction here. What we're going to say equal to, this is equal. We're going to, as we said, we're going to take 30 and get its prime factorization. Okay, 30 is even. Okay, we divide it by 2. I'm sorry. 30 divided by 2, that's 15 here. Remember that? This 2 is a prime number. We circle that. We will need it. And 15 is a composite number. And 3 and 5. Because 3 times 5 is 15. So we can simplify we can write the prime factorization of 30 as 2 times, it's all multiplication, times 3 times 5. That's another way I can write 30. We're going to do the same for 36. We are going to do the same for 36, okay? So 36, I'm going to write it here. Okay, this is 2. And again, 36 is even. 2. We divide 36 by 2. We get 18. We divide 18 by 2. 18 is even still. We get 9. And 9, we get 3 here and 3 there. So we get all those prime numbers here. And we circle them. Let's circle them. Circle this one. Circle that one. Circle that one. These are the numbers we're gonna use. So 36 can be factored as 2 times 2. How many 2's? We get 2 2's and 2 3's. Times 3 times 3. Okay. We are simplifying this fraction using prime factorization. And as you can see, when I say using prime factorization, you see 2 divided by 2, that's 1. So this one gets cancelled out. 2 divided by 2 is 1. So the 2 and the 2 here can get cancelled out. 3, you get a 3 here. Yes, see that 3 here? This gets cancelled out too. Okay. And the 5, we have the 5 here, we don't have it down here. And we get the 2 down here, we get no more 2's up here. We get 3 down here, we get no more 3's up here. So this should be it. So what we're going to do, let's simplify now. This is what is called simplifying fraction. So we're going to take away what's needed, and we're going to just simplify the fraction. So what is left? This is gone. This is gone. So get the 5 left here. This is 5. 5. What's left again? We didn't take out this 2. I'm going to put it here. It's 3 here. This is what's left. And in the end, we get 5 over 2 times 3 is equal to 6. So our answer is 5, 6. So you have used prime factorization to simplify this fraction. You have used the prime factorization to simplify this fraction. Okay. Let's do a second example using prime factorization to simplify the fraction. All right. Let's say we get 24 over 56. 24 over 56. This is a fraction that we are given, and whose prime factorization we need to find. All right, so 24, you're going to take the first number. Okay, you're going to take 24, you're going to write it here, and you're going to take 56 and you write it here, because you get these two numbers in question here. So 24, you're going to get the prime factors of 24. The prime factors of 24, you know, as you're getting closer to what we're doing here, you can decompose 24 whichever way you want. But since some of you are learning it, we're going to decompose 2 and 12, right? 2 times 12 is 24. And then we get a 2 here. We don't go any further with that 2. 12 is 2 and 6. Okay? We get these 2 here. And 6 is 2 and 3. So basically, 24 over 56 is equal to, I'm going to take all these prime factors and put them for 24. These are the prime factors for 24. It's 3 2's, so 2 times 2 times 2 and 1 3 times 3. Because 2 times 2 is 4, times 2 is 8, times 3 is 24. We're good here. So now let's go do the same with the 56. 56 2. 56 divided by 2, that's 20. Okay, 56. What do you think it is, guys? Okay, so 56 divided by 2, and this is equal to 13, right? This is 13. 56. I mean 27. 27. But not 13. This is going to be 20. 27. 56 divided by 2. All right. 56 divided by 2. This is 27. Because 27 times 2. I'm sorry. 28. 28. So 28. 28 times 2 is 56. Okay. And we get 2 again. This is 2 divided by 2 because 28 is even. Okay. 28 divided by 2. Okay. That's 14. 14 divided by 2. And we get 7. 2 and 7. All right. 2 and 7. So we get all those factors here of 56. This is 2. This is 2, 2, and 7. So 56 is equal to how many 2's? 3 2's. So 2 times 2 times 2 and 1 7. Okay, and once we get here, let's go and simplify this fraction. Let's go and simplify this fraction. Get 1 2 up, 1 2 down. So this gets cancelled out. 2 2 cancelled out. 2 2 cancelled out. So what is left? Whatever you see, guys. Whatever you see. What do you see? You see 3 over 7. So 24 over 56 is the same as 3 over 7. So 3 over 7, 24 over 56 is equal to 3 over 7. This is the fraction you find when you simplify. Then both of these are called, 24 over 56 is equal to 3 over 7. This is called equivalent fraction. So when they're equivalent, so they're the same. But remember, if you were to do a problem, the answer you need to put, it should be the simplified answer. The simplified answer is what you see. Is that 3 over 7? Is that 3 over 7? Okay, guys. I hope this helps. And let's go and use the second method to simplify fraction. Second method. The first one was using prime factorization. So the second one, the second method, the second here, is using GCF. All right, we're gonna use GCF to factor to simplify fractions. Okay, we use prime factorization, simplify fraction, and now we're gonna be using the GCF to simplify fractions. So now let's go and talk about the GCF. GCF stands for greatest. So the G is for greatest, the C is for common, the F is for factor. So as you can see, you see factor again. The way we're going to write an expression, a number, as a product of 2 or more expressions or number, because we're talking about factors here. You cannot find a GCF of just one number. Okay, it takes 2. It takes 2 numbers for you to find the GCF of. But if you're simplifying fraction using greatest common factor, which is the GCF, okay, we get some step here. I'm going to give you that step. Step number one. Find the factors of each number. Find the factors of each number. That's number one. Number two is to find which factors the numbers have in common. Which factors the numbers have in common. And number three, determine which factor of the common factors is the greatest. You see, that's the keyword here. This is the keyword we have here. Greatest. G. That's the G. Which factor is the greatest? Common. And this is what we're going to look for. Factor. All right, and we get the last one, which is step number 4. Step number 4, divide the GCF. Divide the GCF evenly, guys, into the numerator and denominator. Okay, guys, and if you want to pay attention, this is what we're going to do next. And hopefully, if you want to write this down, write it down. If you want to watch it in your video, watch it. And we're going to do what we just mentioned here. Okay, we're going to do what we just mentioned here. Now let's go and do some examples. Let's go and do some examples. We're gonna simplify using the greatest common factor. Let's say they give you this fraction, 30 over 36. Okay, 30 over 36. And remember, the first thing we're gonna do, we're gonna find the factors of each number. Find the factors of each number. I want to show you something. If you put 30 over here, okay, you put 30, that's 30, and let's find the factors of 30. 30 always start with 1. Okay, guys, 1. 30 is equal to 1 times 30. See, 1 times 30 is 30. Now let me take number 2. Is 30 divided by 2? Yes. 30 is equal to 2 times 15. 30 and 3. 3. 30 is equal to 3 times 10. Go for 4. This is 1, 2, 3, 4. 30 is not divisible by 4. I don't need 4. I don't need to use 4. 5. 30, yes. I skip 4. You see that? I skip 4. I take 5. 5 times 6 is 30. And these are the factors. You see, 1 times 30 and so on and so on. The factors are pairs of factors. So now, let me take another number. If I go 5, guys, After 5, I say 6, right? And now as I'm going to take 6, it's going to be 6 times 5. So I don't need to go beyond 5 times 6 because I'm going to get the same thing again. I don't need that. I don't need that. I need to stop here. Since I get the 6 here, I work like this. These are the factors. 1, 2, 3, 5, and I go to 6 over here. 6, 10, 15, 30. These are the factors of 30. So factors of 30 is, I'm going to put 30 here. As you can see, we get the factors of 30 as they are, because I just want to make sure that you understand what's going on here. The factors of 30, the factors 1, 2, 3, 5, 6, 10, 15, and 30. These are the factors of 30. I go and do the same with 36. Okay, so I will start with 1 times 36. And I'll take 2 times 18. Because 2 times 18 is 36. I take 3 times 12 is 36. 4 times 9 is 36. Okay. 5. Oh, 5 doesn't go into 36. Okay, 6. Yes, 6 times 6 is 36. 7. 8. No. 9. Yes, but 9 is already here. So I start at 6 here because I'm going to take all of it. All of it. All right. So I'm going to write here factors of 30. You see, guys, factors of 30. This is factors of 30 is 1. I'm going to put the 1 here. You see, that's the 1 I have here. I'm going to put 1. I did it. Ooh. I'm going to put 1, 2. You see, I have them here. 3, 5, 6, 10, 15, 30. These are the factors of 30. I do the same. Factors of 36. Go back to it again. Factors of 36. That's 1, 2, 3, 4, 6. Write them here. 1, 2, 3, 4, 6, 9, 12, 18, 36. 9, 12, 18, 36. So we get factors of 30, all these numbers here, and factors of 36, all these numbers here. So now let's keep following our steps. So the first step, find the factors of each number. Okay, we just got that, and find which factors are common for both of them. So we get the factors of each number, and now we're going to check to see which factors are common for both of them. The common factors, we get a 1 here. That's a common factor. We get a 2 here too. Okay, that's another common factor. It's common for both of them. 3. It's common for both of them. Oh, no, not 4. I get 4 here. I get 5 here. No 5 down here. Not 4. We get 6 for both of them. Yeah. 10 is here. We don't get 10 for 36. 15, 30. We don't get that for 36. And now we don't have either the factors of 36, the 12, 9, 12, 18, 36 in 30. So we get 4 common factors here. So what I'm going to do here, I'm going to write the common factor. I'm trying to do this with you guys methodically, and as you know and understand it, you will do it quickly next time you're simplifying fractions. So I'm going to write here common factors. What are they? The common factors are the one we have here. That's 1. They're common for both numbers. 1, 2, 3, and 6. Oh, we only have 4 common factors. But the common factor, you see, if they don't say greatest, you might think that 2 is the factor you're looking for. But greatest eliminates all the other competitions. Greatest eliminates 1, it eliminates 2 and 3, because 6 is the greatest. That's what I want you to pay attention to, guys. If that said simplifying fraction using common factors, would have been a lot of work for us. Would have done it with 1, 2, 3, and 6. But they want to tell you which number to use. So they said the greatest common factor. So what is the greatest here? Between 1, 2, 3, and 6, we all agree that this is 6. So I'm going to write here the GCF is equal to 6. That's the 6. Okay. That was step number 2. That was step number 3. This is step number 3. And you get the factors here. That's step number 1. You take the common factors. That's step number 2. And now you get the GCF. That's step number 3. And step number 4, you divide the GCF evenly. You divide. Okay, when I say divide, I'm dividing the GCF evenly. When they say evenly, whatever you do on top, you do it at the bottom here. Whatever you do for 36, you do it for 30, you do it for 36. And divide by the GCF, which is by 6. So guys, 6 is your GCF. This is how you do it. You go by it. This is 6 here. And the fraction becomes, so 30 divided by 6 at 5. And 36 divided by 6 is 6. And this is it, guys. That's your answer here. All right, that's your answer here. So the fraction 30 over 36 using GCF to simplify it is 5 over 6. 5, 6. Okay. All right, let's do another example. Let's do another example using GCF to simplify fraction. We're going to do another example, and this would be it for this video. Okay, we get let's put it this way. 43 12 over 18. And guys, as you keep practicing and you keep doing this, there'll be a time you won't have to go through all of this we went through. But right now, if you want to go by that, you just go by to find those factors. Because as you get better and better every day, and once you get this fraction here, you know exactly what is the GCF, and you just divide that by that GCF. So, but before then, let's make sure that we get this right. Let's do it again. This is 1 times 12, and we get 2 times 6. we get 3 times 4. So 4, we're gonna 4 again, we're gonna get 4 times 3. We don't have to keep repeating the same numbers. So the factors of GCF of 12, the factors of 12, I'm gonna write 12 here. The factors are 1, get the 1 here, 2, 3, 2, 3, we get 4, we get this 4 here, because you get the factors like this from up here, okay, and you go back up. All right, and you get 1, 2, 3, 4, we get this 4 here, 6, and 12. That's for 12. Okay, let's go for 18 now. The factors of 18, and I'm going to take 18 and put it, I want to make sure that 18, this is 1 and 18. Okay, 1 after 1, I say 2, 2 and 9, and 3 and 6 and 4. No, because 18, 4 doesn't divide 18. 5, no. 6, yes. Oh, I go back to 6 again. So I step here at 3. So I step here, because if I go back to 6 again, I already have 6. So, and you know the rule. So I start counting whatever I have here at the top here. I take from the 1, I come down, I go down here, and I go back up to get my factors. And the factors of 18 are 1, 2, 3, 6, 9, and 18. That's step number 2. Number 3. No, step number 3. So what we're going to do, we're going to find the common factors. Common factors. We get a 1 here. That's 1. We get 2 common factors. 3 common factors. 4, no. 6 common factors. There you go. So once we get those common factors, they are 1, 2, 3, and 6. 4 of them. And what is the GCF, guys? GCF is equal to the greatest common factor is 6 again. Oh, that's 6 again. So what we're going to do? We're going to divide each number evenly by 6. So this is 12 divided by 6 and 18 divided by 6. So the answer is 12 divided by 6, this is 2, and 18 divided by 6, that's 3. So the answer, so 12 over 18 is equal to 2/3. So you have used GCF to simplify the fraction 12 over 18, and the equivalent fraction is 2 over 3, or 2/3. Guys, this is it for this video. Subscribe, and if there is something you want to learn, and please use the comment to do so, and I'll be waiting for the next video. It's coming very soon. Bye-bye.